Good morning and welcome to the Royal Swedish Academy of Sciences. The Academy met in session this morning to decide on this year's Nobel Prize in Physics, and we are now ready to announce it. And it took a little while for us to get in touch with the Nobel laureates, so therefore we are a few minutes late. I apologize for that. I'm Göran Hansson, I'm the Secretary General of the Academy. And with me today is, on my right, Professor David Haviland, who is the chairman of the Nobel Committee for Physics. And on my left, Professor Danielsson, who is, among many other things, also a member of the Nobel Committee. Before we announce the prize, I would like to thank all of you who are here in the session room today. And I regret that we have to operate under restrictions imposed by the corona pandemic. And I really appreciate that you are complying with these restrictions, so thank you. I must also apologize to all the journalists who cannot be here in the session room this year. Normally we are close to 90 people in this room. Now we must be fewer than 30 persons altogether. And therefore many representatives of the media will have to follow the press conference over a video link. We're really sorry that we could not admit you, and we hope for your understanding, and we're offering interviews with Nobel Committee members and other experts immediately after the press conference. So thank you for your understanding. Now, over to the Nobel Prize in Physics. This year's prize is about the darkest secrets of the universe. Årets Nobelpris handlar om universums mörkaste hemligheter. Kungliga Vetenskapsakademin har beslutat att utdela 2020 års Nobelpris i fysik med ena hälften till Roger Penrose för upptäckten att bildandet av svarta hål är en robust förutsägelse av den allmänna relativitetsteorin. Och med andra hälften gemensamt till Reinhard Genzel och Andrea Ghez för upptäckten av ett supermassivt kompakt objekt i Vintergatans centrum. The Royal Swedish Academy of Sciences has today decided to award the 2020 Nobel Prize in Physics with one half to Roger Penrose for the discovery that black hole formation is a robust prediction of the general theory of relativity. And the other half jointly to Andrea Ghez and Reinhard Genzel for the discovery of a supermassive compact object at the center of our galaxy. Die Königliche Schwedische Akademie der Wissenschaften hat heute beschlossen, den Nobelpreis für Physik des Jahres 2020 mit Penrose für die Entdeckung, dass die Bildung von schwarzen Löchern eine robuste Vorhersage der allgemeinen Relativitätstheorie ist, und die andere Hälfte gemeinsam an Reinhard Genzel und Andrea Ghez für die Entdeckung eines supermassereichen, kompakten Objekts im Zentrum der Milchstraße zu verleihen. L'Académie royale des sciences de Suède a décidé ce jour d'attribuer le prix Nobel de physique 2020 avec une moitié à Roger Penrose pour la découverte que la formation de trous noirs est une prédiction robuste de la théorie de la relativité générale. Et l'autre moitié, conjointement à Reinhard Genzel et Andrea Ghez pour la découverte d'un objet compact supermassif au centre de notre galaxie. Королевская академия наук Швеции решила сегодня присудить Нобелевскую премию по физике одну паладину Роджер Пенроуз за открытие того, что образование черных дыр является надежным предсказанием общей теории относительности. Вторую паладину равна Reinhard Genzel и Andrea Ghez за открытие супермассивного компактного объекта в центре нашей галактики. And you have the pictures of the new Nobel laureates on the screen behind me. Roger Penrose was born in Colwich in England and got his PhD at Cambridge University. He's now emeritus professor in mathematics at the University of Oxford. Reinhard Genzel was born in Bad Homburg vor der Höhe in Germany. He got his PhD at the Universität Bonn, and he's currently director at the Max Planck Institute for Extraterrestrial Physics in Garching in Bayern in Germany. And he's also a professor at the University of California at Berkeley in the United States. Andrea Ghez, finally, was born in New York City. She got her PhD at Caltech in Pasadena in California, and she's currently professor at the University of California, Los Angeles in the United States. Now, we are not requesting that the Nobel laureates come to Stockholm in December this year to pick up their prizes. Because of the pandemic, we plan for digital Nobel lectures and a digital prize ceremony with laureates participating over video links. We are still working on these events together with the Nobel Foundation and, of course, from now on with the laureates themselves. And we'll come back with more information as soon as it becomes available. But already at this stage, I can assure you that the Nobel laureates will receive their awards before the end of the year, and that they will be invited to Stockholm next time we can celebrate the Nobel Prize in the traditional way here in Stockholm in December. And with that, I'd like to ask David Haviland, chairman of the Nobel Committee for Physics, to make some remarks. David, please.
Thank you, Göran. On behalf of the Nobel Committee for Physics, I would like to congratulate the laureates in receiving the 2020 Nobel Prize. This year's prize celebrates the discovery of one of the most exotic objects in our universe, the black hole. For many years, physicists questioned the very idea of a black hole, treating it as a peculiarity in our theory of gravity. Roger Penrose showed that black holes might really exist, forming in a stable and robust process consistent with the theory of general relativity. Reinhard Genzel and Andrea Ghez led research teams to make precise observations over many years, which pointed to the existence of a supermassive black hole in the center of our very own galaxy. My colleague in the Nobel Committee for Physics, Professor Ulf Danielsson, will tell us more about the contributions of this year's laureates to the discovery of black holes.
Thank you, David. And now, Ulf, the floor is yours.
As early as the end of the 18th century, the English astronomer John Michell and the French scientist Pierre-Simon Laplace speculated that there might exist objects with a gravity so strong that not even light can escape. We now call such objects black holes. To create them, you would need to compress the sun into a region only a few kilometers across, or to squeeze the Earth down to the size of a pea. But it was only in 1915 when Einstein formulated his general theory of relativity that we had a mathematical framework powerful enough to describe such objects. Physicists, Einstein himself included, were confused for decades. The mathematics was too complicated. Could something like that actually occur in a real universe? And then, in 1965, inspired by the discovery of new violent phenomena in the universe in need of an explanation, Roger Penrose published a remarkable paper. He introduced new mathematical tools and proved with mathematical rigor that the formation of black holes is an inevitable consequence of general relativity. In a universe governed by general relativity, the formation of black holes is a natural and expected process. Let us study now a black hole a little bit more closely. In general relativity, there's an intimate relation between gravity and time. Down at my feet, time runs a trillionth of a second slower per hour than it does up in my head. And if you have a black hole, time even seemed to stand still at the horizon of the black hole. Now, I can point towards the black hole and say, there it is. There is the center of the black hole. My finger is stretched along a direction of space. But if I then bring my finger a little bit closer and let the tip of my finger go through the horizon and enter into the interior of the black hole, I will make a startling and somewhat worrying discovery. The direction inwards is now time, and the tip of my finger will be in my far future. And it will be as difficult to pull my finger back out again as it would be to travel backwards in time. Furthermore, my finger will be torn apart, and the tip of my finger will be carried by time all the way into the center of the black hole, where time itself ends, and the known laws of physics cease to apply. But if such objects now actually exist in the real universe, then how could you find them? Well, actually, already in 1783, John Mitchell had an idea. What if there are other luminous objects, such as stars, moving around the black hole? Then one could infer the existence of the black hole by following the motions of the stars. But it would take more than 200 years before this dream would come true. And it was Reinhard Genzel, Andrea Ghez, and their teams who did it. They turned their telescopes towards the center of our galaxy, 26,000 light years away, where there were suspicions that something strange was going on. The heart of our galaxy, the heart of the Milky Way, is hidden inside of a dense cloud of dust. And you have to look in the infrared to reveal its secrets. What they found was incredible. They could see several stars moving around something that they couldn't see. And it was one star in particular that caught their attention. It took the star around 16 years to complete its orbit. At closest approach, it was no more than 17 light hours away from the invisible object. Calculations show that 4 million solar masses is hiding there. There is no other explanation than a supermassive black hole. This year's laureates have uncovered secrets in the darkest corner of our universe. But this is not just an old adventure coming to its triumphant conclusion. It's a new one beginning. As we probe ever closer to the horizons of the black holes, nature might have new surprises in store.
Thank you very much, Ulf, for that excellent introduction. And now it's time for questions. When you ask questions, if you could please push the button on the microphone stand so that it comes, your voice is picked up. Actually, we hope to have one of our new Nobel laureates with us on a phone line. Dr. Andrea Ghez, are you there?
Yes.
Hello, this is Göran Hansson again. I'm the guy who called you about an hour ago to give you the good news. And we are now in the middle of our press conference, and I wonder if you're ready to take some questions.
I'd be delighted.
Who would like to start? Thomas Honheide, fast as always.
Hello, Professor Ghez. Congratulations. I'm just curious. This is Swedish television public service. I'm just curious to hear what went through your mind when you saw that sign that there must be something lurking in the middle of the Milky Way.
I think the first thing is doubt, that you have to prove to yourself that you're really seeing what you think you're seeing. So both doubt and excitement, it's that feeling of being at the frontier of research where you have to always question what you're seeing. So it's a combination of things.
More questions? Yes, I think it's David Keaton from Associated Press. You'll get a microphone there.
Yes, David Keaton from the Associated Press. Thank you, Professor. At this moment in time, the research that is being rewarded here today dates back for decades. And like you just mentioned there, this disbelief at the beginning, the importance of science and the belief in following the facts is quite crucial. At this moment in the United States, where science is somewhat in doubt, what message do you have maybe today?
Oh, that science is so important, and pursuing the reality of our physical world is just critical to us as human beings. I think today I feel more passionate about the teaching side of my job than I have ever, because it's so important to convince the younger generation that their ability to question and their ability to think is just crucial to the future of the world.
Thank you. Please, we have a question. So, Professor Ghez, did you hear the questions?
Unfortunately, I did not hear that question.
Okay, could you repeat then?
Okay, you're the fourth woman to receive this prize. What do you think about that? That was my first question. And the other question is, do you understand what's happening inside the black hole? I mean, time is stopping. What time is it stopping at? Is it stopping now or at the end of the time? Or, well, do you have any way of explaining that so that we can understand it?
I did hear that, those two questions. So let me take the first. I'm thrilled to receive the prize, and I take very seriously the responsibility associated with being, I guess, as you said, the fourth woman to win the Nobel Prize. I guess I hope I can inspire other young women into the field. It's a field that has so many pleasures, and if you're passionate about the science, there's so much that can be done. Let me take the easier question, which is almost, what is the black hole? We don't know. We have no idea what's inside the black hole, and that's what makes these things such exotic objects. They really represent the breakdown of our physical understanding of the laws of physics. So that's part of the intrigue, is that we still don't know. It really pushes forward on our understanding of the physical world.
Question over here.
Hello, this is Göran Spolander from TT News Agency, Swedish News Agency. First, I want to congratulate, of course, to the prize. And then, perhaps you just answered it, but how would you say that this discovery of a black hole far, far away has changed life here on Earth?
Well, it really represents the basic research. You don't always know how it's going to affect our lives here on Earth, but it is pushing the frontier of our knowledge forwards, both from the point of view of pure physics, understanding what a black hole is, and then also their astrophysical world in the formation and evolution of galaxies. And so today we really accept that these objects are critical to the building blocks of our universe.
Any more questions to Professor Gies? If not, thank you very much again, Professor Gies, and we'll be in touch about the arrangements for December. But thanks so much for being with us at the press conference.
Thank you.
Bye-bye for now. Now, any questions for the panel? All crystal clear? If there are no further questions, thanks so much. Now there will be individual interviews taking place here, out there, and nearly everywhere in the building. And our staff will help you find your way. Please be careful and keep the distance when you exit the room. And then, of course, you're all very welcome back tomorrow for the Nobel Prize in Chemistry. Thank you.